You woke up this morning. Maybe your smart alarm went off, pulling the latest traffic data from Google Maps to decide the perfect moment to wake you. You rolled over, grabbed your phone, and spent 10 minutes scrolling through a perfectly curated, infinitely long feed of videos, memes, and news from across the country. You saw a jacket you liked on Instagram and bought it with a single tap. You ordered a coffee on the Starbucks app, checked your bank balance with Chase, and maybe sent your friend $20 for last night's pizza on Venmo. Then you asked Alexa to play a podcast for your commute. You just performed a dozen digital miracles before you even finished your first coffee. And you probably didn't think twice about it. But what if I told you that every single one of those actions, every swipe, tap, and voice command, was part of a hidden, global symphony conducted from inside massive, windowless buildings scattered across the United States? What if I told you that you don't really own the apps on your phone, you just have a ticket to a show running on someone else's supercomputer hundreds, maybe thousands of miles away? This isn't science fiction. This is the cloud. And it's the most powerful and most misunderstood force shaping your life in America today. The term cloud is frankly terrible. It makes you think of something fluffy, weightless, and ethereal. But the reality is the exact opposite. The cloud is not a cloud. It is a planet-spanning network of colossal, hypersecure, power-hungry warehouses filled with millions of computers, all wired together. These are called data centers. They are the physical heart of our digital world. There are sprawling campuses of them in places like Ashburn, Virginia, known as Data Center Alley, or the Dalles, Oregon, built along the Columbia River for cheap hydroelectric power. These are the factories of the 21st century. And what they manufacture is reality itself: your social feed, your movie stream, your bank statement, your rideshare. We're about to pull back the curtain on this invisible world. This isn't just for tech geeks in Silicon Valley. This is for every single person in the United States who uses a smartphone, watches Netflix, or has a job. Because understanding the cloud is understanding the new American economy. It's understanding who has the real power, how tiny startups can challenge billion-dollar giants overnight, and how the very fabric of our daily lives is built on a foundation of rented computer power. By the end of this journey, you won't just understand a buzzword. You'll see the world differently. You'll have a new lens to view the technology you use every single day. To really get it, we have to go back in time, not that far, maybe 15 or 20 years. Imagine you and your buddy have a brilliant idea for a new app. Let's call it Burger Dash. It lets people in your city order from the best local burger joints. Fantastic idea. But in the year 2005, how do you make it real? First, you need a computer to run the website. Not your laptop, a special powerful one called a server. So you go to Dell's website and you spend $5,000, maybe $10,000 on a server. It arrives in a giant box. Now what? You have to find a place to put it. Maybe you stick it in a closet in your office. You have to make sure the air conditioning is blasting so it doesn't overheat. You need a super fast, super reliable internet connection, which costs a fortune. You have to worry about the power going out, so you need a backup generator. You have to become an expert in managing this machine, updating its software, protecting it from hackers, replacing parts when they break. All of this before you've written a single line of code for Burger Dash. All of this before you've made a single dollar. But let's say you do it. You launch Burger Dash and it's a hit. People love it. Suddenly you have thousands of users trying to order burgers at the same time, especially on Friday nights. Your one little server in the closet starts to smoke. The website crashes. Orders fail. Angry customers start calling. Your dream is turning into a nightmare. You need more power fast. So you rush back to Dell's website, order 10 more servers, and wait a week for them to arrive. By the time you get them all set up, your customers have moved on. Your startup is dead. This was the reality for a generation of entrepreneurs. You had to be an expert in real estate, power grids, and hardware maintenance just to run a website. The cost and the risk were enormous. Now let's run that same scenario today in the world of the cloud. You have your idea for Burger Dash. Instead of buying a server, you go to a website, let's say Amazon Web Services, Microsoft Azure, or Google Cloud. With a credit card, you rent a virtual server. You don't see it, you don't touch it. It's just a slice of a massive computer sitting in one of those data centers in Virginia or Oregon. Takes about 2 minutes, and it might cost you pennies per hour. You launch Burger Dash. Starts to get popular. But this time, you've set it up to be elastic. This is the first superpower of the cloud. Elasticity means that when traffic surges on Friday night, the cloud automatically, in milliseconds, creates more virtual servers for you. One server becomes 10, 10 become 100. It's like a digital accordion. expanding to meet the demand perfectly. Your website never slows down. Every customer gets their burger order in. Then, at 2 a.m. when everyone's asleep, the cloud automatically shrinks your system back down to 1 or 2 servers. You only paid for that massive power for the few hours you actually needed it. You didn't have to buy 100 servers that would sit idle and collect dust for the rest of the week. This is how Netflix handles millions of Americans logging on at 8 p.m. on a Saturday, and how a small e-commerce site can survive a massive traffic spike from a Super Bowl commercial. That's elasticity. The second superpower is what this implies: you pay for it like a utility. Think about the electricity in your home. You don't build a power plant in your backyard. You just plug into the grid, and at the end of the month you get a bill for exactly how many kilowatt hours you used. The cloud is the same thing for computing power. It turned a massive upfront capital expense buying servers into a simple operational pay-as-you-go expense. This is what blew the doors open for innovation across America. It leveled the playing field. A couple of college kids in a dorm room now had access to the exact same world-class, infinitely powerful computing infrastructure as a Fortune 500 company. They just had to pay for the slice they used. And the third superpower is reliability. What happened in the old days if that server in your closet went on the fritz? Your entire business was dead in the water. But your virtual server in the cloud? It's not just one machine. It's an abstraction. The cloud provider has built-in redundancy. Your app isn't just running in one data center in Virginia. The provider can be automatically making copies of it in Ohio or California. If a whole data center gets knocked out by a hurricane, your app seamlessly fails over to another location, and your users never even notice. It's like a chain of forts protecting a frontier. If one fort falls, the others are still standing, all connected, all working together to keep the system running. So this is the fundamental shift. We've gone from a world where every company, big or small, had to own and operate their own digital factories, to a world where we all just rent space from a handful of mega landlords who have built the most advanced digital factories in human history. We traded ownership for convenience, scalability, and power. This changed everything. It's why you can stream 4K movies instantly, why your food can be delivered in 30 minutes, and why a tiny startup can become a household name in 18 months. They aren't building the infrastructure, they're renting it. But this raises a critical question. If we're all just tenants in this new digital America, who owns the land? Who are these mega landlords that hold the keys to the entire modern economy? The answer to that question is where this story gets truly fascinating, and it starts in a very unlikely place. Not with a computer company, but with an online bookstore from Seattle. That online bookstore was, of course, Amazon. And in the early 2000s, Amazon wasn't the unstoppable global titan it is today. It was a scrappy, chaotic, and rapidly growing e-commerce company, facing a crisis that threatened to tear it apart from the inside. The problem wasn't competition or logistics or even selling books. The problem was its own technology. It was a complete and utter mess. Imagine for a moment you're building a house. But instead of a single blueprint, every single team, the plumbers, the electricians, the carpenters, all have their own separate secret blueprints. They don't talk to each other. The plumbing team builds a custom water pump from scratch. The electrical team invents its own form of wiring. The framing team decides to use circular studs instead of rectangular ones. The result would be a Frankenstein's monster of a house. It would be incredibly expensive, take forever to build, and the moment you tried to add a new room or fix a leaky pipe, the whole unstable structure would risk collapsing. That was Amazon in the year 2000. Every new feature, every new product category, from electronics to kitchenware, was like adding a new rickety room to this collapsing house. Each team was building its own infrastructure, its own databases, its own computing resources, all from scratch. They were reinventing the wheel over and over and over again. This created what engineers call spaghetti architecture, a tangled, incomprehensible web of systems where nobody knew how anything truly connected. Launching a new feature that should have taken days was taking months. The website, especially during the crucial holiday shopping season, was creaking under the strain, constantly on the verge of crashing. Jeff Bezos and his team knew this was unsustainable. They weren't just losing time and money, they were losing the ability to innovate. They were being suffocated by their own success. So, in 2003, they made a pivotal decision. They hit the brakes. They mandated that the entire company had to be rebuilt on a new foundation. The goal was to break down their monolithic, tangled mess into a collection of small, independent, and reusable services. Think of it like this: instead of building a whole new custom car every time, They would create a set of standardized, perfectly engineered Lego bricks. One brick for user authentication, logging in, another brick for the shopping cart, another for processing payments, another for storing product images. Each of these Lego bricks would be a service, and they would all talk to each other through a standardized method called an API, or Application Programming Interface. An API is just a fancy term for a contract. It's like the standardized plug on an appliance. You don't need to know how the toaster works inside. You just need to know that if you plug it into the wall socket, it will get power and toast your bread. Similarly, the shopping cart team didn't need to know how the payment team's code worked. They just needed to know that if they sent a request to its API with a credit card number and an amount, it would either say approved or declined. This was a revolution in how to build software, and it was born out of pure desperate necessity. It was called a service-oriented architecture, and it transformed Amazon. Teams could now work independently and move incredibly fast. They could grab these internal Lego bricks off the shelf and snap together new features in a fraction of the time. They had solved their crisis. They had built a stable, scalable, and efficient foundation for their retail empire. And for most companies, the story would have ended right there. They fixed their internal problem. Mission accomplished. But this is where the story takes a turn from a simple corporate reorganization into one of the most audacious business pivots in American history. As they were building these internal tools, a couple of engineers, Benjamin Black and Chris Pinkham, along with their boss, Andy Jassy, had a stunning realization. The problems they had just spent years and hundreds of millions of dollars solving, the need for reliable storage, for on-demand computing power, for scalable databases, these weren't just Amazon's problems. They were everyone's problems. Every startup, every company, every developer in the world who wanted to build something on the internet was facing the exact same nightmare. They were all forced to play the guessing game of infrastructure. You'd have to buy or lease physical servers, those big, loud, humming boxes, and put them in a data center. But how many do you buy? If you buy too few and your app suddenly goes viral, like when you get featured on the front page of the New York Times, your site crashes and you lose your one big shot. If you buy too many, you're just burning cash on expensive hardware that sits there doing nothing 99% of the time. It was a massive, expensive, and risky barrier to entry. And here was Amazon, sitting on the most sophisticated, scalable, and efficient infrastructure on the planet, which they had built to run their own store. The epiphany was this: what if they took their internal Lego bricks, the services for computing, for storage, for databases, and cleaned them up, put a price tag on them, and rented them out to the rest of the world over the internet? What if they could turn their biggest internal expense into their next big product? It was a crazy idea, a truly insane idea at the time. Remember, Amazon was an online retailer. This would be like your local grocery store, after building a really efficient trucking and warehouse system for itself, deciding to rent out its trucks and shelf space to other competing grocery stores. It made no sense to Wall Street. It made no sense to the tech press. Why would a company that sells books and diapers want to get into the brutally complex business of enterprise computing? But Bezos and Jassy saw something no one else did. They saw that the raw ingredients of the digital world, computing power and data storage, were about to become a utility, just like electricity or water. You don't build your own power plant to turn on your lights. You just plug into the grid and pay for what you use. They believed computing was headed in the exact same direction. So, in a now legendary 6-page memo, they laid out the vision for what would become Amazon Web Services, or AWS. In 2006, with almost no fanfare, Amazon quietly launched its first 2 major cloud services. The first was called S3, which stands for Simple Storage Service. It was, in essence, an infinite hard drive in the sky. You could store any amount of data, from a single photo to a terabyte of video, and only pay a few cents per gigabyte. It was incredibly reliable and accessible from anywhere. The second was EC2, the Elastic Compute Cloud. This was the real game changer. EC2 allowed you to rent a virtual server, a slice of one of Amazon's powerful computers, by the hour. Need more power for a product launch? Click a button and spin up 1,000 servers. Is traffic slow at 3 a.m.? Click another button and shut them all down and stop paying instantly. This was the moment the world changed. The massive, expensive barrier to starting a tech company had just been vaporized. Suddenly, 2 college kids in a dorm room in the USA had access to the exact same world-class, billion-dollar infrastructure as a company like General Electric or Bank of America. They didn't need millions in venture capital to buy hardware anymore. All they needed was a credit card. This single innovation is the bedrock upon which the modern app economy was built. A small startup called Animoto, which made custom video slideshows, was built on EC2. One weekend, they launched a Facebook app, and their user base exploded from 50,000 to over 750,000 in just 3 days. In the old world, they would have instantly crashed and burned. In the new world of AWS, they simply scaled up from 50 servers to 5,000 servers over the weekend to handle the load, and then scaled back down on Monday. A new company called Dropbox was born, using Amazon S3 to offer everyone a personal folder that lived in the cloud. And a little DVD by mail service called Netflix decided to bet its entire future on this new platform, moving all of its streaming infrastructure to AWS to enable its global expansion. Amazon had just invented a new kind of digital real estate and was giving away the keys. They had a 7-year head start on the rest of the world. But they weren't the only tech giant in America. And while they were busy quietly building an empire in plain sight, their biggest rivals in Redmond, Washington, and Mountain View, California, were about to wake up and realize they were years behind in the most important technological race of the 21st century. While Amazon was forging this new frontier, the established titans of technology were living in a different reality. In Redmond, Washington, Microsoft was the undisputed king of the enterprise. Their software ran the world's businesses. Windows Server was the operating system of the corporate data center. Microsoft Office was on every desktop. They were a machine built to sell software licenses, packaged neatly in boxes or through massive enterprise agreements. Their entire business model, their culture, their identity was based on selling a product that you owned and ran yourself. The idea of renting out computing power slice by slice was not just foreign, it was antithetical to their DNA. It was like telling a car manufacturer to stop selling cars and start selling bus tickets. But inside this corporate battleship, a few people on the bridge saw the iceberg ahead. One of them was Ray Ozzie, the legendary programmer who created Lotus Notes and had taken over from Bill Gates as Microsoft's chief software architect. In 2005, a year before AWS officially launched, Ozzie wrote a now famous internal memo called The Internet Services Disruption. It was a 5,000-word wake-up call, a warning shot fired across the bow of the entire company. He argued that Microsoft's dominance was being threatened by a fundamental shift towards services delivered over the internet. He saw a future where software wasn't a product you bought, but a service you subscribed to. He was describing the cloud, and he was pleading with the company to turn the ship, and turn it fast. But a company like Microsoft in the mid-2000s doesn't turn on a dime. It was an empire of divisions, each with its own profit and loss, each protective of its own turf. The Windows Server division saw the cloud as a direct threat to its multi-billion-dollar business. Why would a company buy a Windows Server license if they could just rent a virtual server from someone else? It took years for Ozzie's warning to truly sink in, and by then, AWS was no longer a secret experiment. It was a rapidly growing business. Panic began to set in. Microsoft executives started seeing startups and even some of their own customers choosing AWS over their own products for new projects. The response was a classic Microsoft maneuver. Throw immense resources and brilliant engineers at the problem. They greenlit a secret project codenamed Project Red Dog. The goal was ambitious, perhaps too ambitious. While Amazon had started with simple, raw building blocks, Microsoft tried to build a sophisticated, polished platform from day one. They weren't just building a cloud. They were building a cloud operating system. They wanted to create a seamless experience for the millions of developers who were already familiar with Windows. In 2010, 4 years after AWS opened its doors, Project Red Dog was officially unveiled to the world as Windows Azure. The name was strategic. Windows was meant to signal to their massive base of enterprise customers that this was a safe, familiar bet. Azure was meant to evoke the limitless expanse of the sky, the cloud, but they were 4 years late. In the technology world, that's a lifetime. Amazon already had a commanding lead, a vibrant ecosystem of users, and a pace of innovation that was relentless. Microsoft wasn't just entering a race. They were starting several laps behind the leader. Meanwhile, 100 miles down the coast from Amazon in Mountain View, California, the other giant was having its own very different identity crisis. If any company on Earth should have dominated cloud computing from the start, it was Google. By the mid-2000s, Google had already built the most sophisticated, planet-spanning computer the world had ever seen. Their entire empire, search, Gmail, Maps, ran on a custom-built infrastructure of millions of servers, all working in concert. They had solved problems of distributed computing at a scale nobody else had even dreamed of. They literally wrote the book on it, publishing groundbreaking research papers on technologies like MapReduce and the Google file system, which would become the foundation for the entire big data revolution. So why weren't they first? The answer is one of the great ironies of modern business history. For Google, their incredible infrastructure was the secret sauce. It was their ultimate competitive advantage. The idea of selling access to it to other companies was like Coca-Cola publishing its secret formula. It was viewed as an internal tool, a weapon to be used to build their own world-changing applications, not a product to be sold to others. They were so focused on organizing the world's information that they missed the opportunity to provide the infrastructure for the world's applications. They did make one early attempt, launching a service called Google App Engine in 2008. But it perfectly illustrated their fundamental misunderstanding of the market. App Engine was what's known as a platform as a service or PaaS. In simple terms, AWS was giving developers a pile of lumber, nails, and a hammer, the raw infrastructure, and telling them to build whatever house they wanted. Google App Engine, on the other hand, was giving them a prefabricated house kit. It was much easier to assemble, but you were locked into Google's specific design, Google's rules, and Google's tools. You could only build the house they wanted you to build. Developers, especially the innovative startups that were flocking to the cloud, didn't want a prefab kit. They wanted the freedom of the raw lumber. They wanted to build new, weird, wonderful structures that no one had ever thought of before. They wanted the control and flexibility that AWS provided. Google, the company built by engineers, had misjudged what other engineers actually wanted. They thought they were making it simpler, but they were actually making it more restrictive. It took Google years to correct this strategic blunder. While AWS was building a multi-billion-dollar business and Microsoft was scrambling to catch up with Azure, Google was stuck in second gear. It wasn't until they finally launched the Google Compute Engine in 2012, their own version of the raw lumber service, that they truly entered the race. But by then, the landscape had been defined. It was a two-horse race for the future of computing, and Google was a distant third. So by the early 2010s, the battle lines were drawn. You had Amazon Web Services, the surprise king of the hill, the innovator who had created the market and now dominated it with a staggering array of services and a cult-like following among developers. They were the default choice, the ones to beat. Then you had Microsoft Azure, the powerful challenger, leveraging its iron grip on corporate America. Their strategy was to go top-down, selling to the chief information officers and IT departments who had trusted Microsoft for decades. They promised a hybrid approach, seamlessly connecting a company's old-school data centers with the new world of the cloud. And finally, you had the Google Cloud Platform, the brilliant but late contender, boasting arguably the most advanced technology, but struggling to translate that technical prowess into market share. They were playing a desperate game of catch-up, trying to convince the world that their secret sauce was worth a taste. The three American tech giants were now locked in a colossal multi-trillion-dollar war for the soul of the internet. They were building data centers the size of small cities, laying undersea cables across oceans, and hiring armies of engineers. But the real revolution, the one that would directly change your life, wasn't happening in their boardrooms. It was happening in the garages and dorm rooms of a new generation of builders, who were about to be handed these new digital superpowers. They were about to use this rented, infinitely scalable infrastructure to disrupt everything, and one of them was about to change the way you watch movies forever. The year is 2007. In Los Gatos, California, a company that mails DVDs in red envelopes is on top of the world. They've slain the giant Blockbuster not with a better store but by eliminating the store entirely. But its co-founder, Reed Hastings, is a professional paranoid. He knows that the very thing that made them successful, the physical disc, the US Postal Service, is a ticking clock. Internet speeds are creeping up. The future isn't plastic, it's pixels. And so they launch a new, almost experimental feature. Watch now. Streaming. First, it's a novelty. The library is small, the quality is okay. But it's powered the old-fashioned way. Netflix, like every other big tech company of the era, runs its own massive, expensive data centers. Warehouses full of blinking lights and humming servers that they own, they manage, they have to physically maintain. Every time you streamed a movie, the request went to one of these buildings, a specific machine word to life, and pushed that data through the internet to your screen. It worked, but it was brittle, and it was about to break. In August of 2008, it happened. A major database corruption. For 3 agonizing days, their entire DVD shipping operation went down. It was a catastrophe. And for the engineers at Netflix, it was a terrifying glimpse into the future. If this one failure could cripple their simple, predictable DVD business, what would happen when millions of people tried to stream high-definition movies all at once on a Friday night during the premiere of a hit show? Their own infrastructure, the one they had spent millions building, was a liability. It was a bottleneck. They realized they couldn't build data centers fast enough to keep up with their own ambition. To go from a national DVD service to a global streaming superpower, they couldn't own the road. They needed to rent a fleet of supersonic jets. This was the moment of truth. They made a decision that, at the time, was considered corporate insanity. They decided to shut down their own data centers and move their entire, sprawling, mission-critical operation onto someone else's computers. They decided to go all in on Amazon Web Services. No major company had ever done this. It was like Ford deciding to stop building factories and instead rent assembly line time from a competitor. It was a bet the company move, and it took them 7 long years to complete the migration, a painstaking process of rebuilding every single piece of their technology from the ground up, not for their own servers but for the cloud. So what did this actually let them do? Why was this the most important decision in the company's history? It comes down to one beautiful, powerful word: elasticity. Think about television in the old days. Everyone watched the finale of MASH at the exact same time. The demand on the broadcast towers was huge, but predictable. Online streaming is 1,000 times more chaotic. Imagine it's 8 p.m. on a Friday. All across the United States, millions of people finish dinner, flop onto the couch and open the Netflix app. The demand on their system skyrockets. In the old world, Netflix would have had to own enough servers to handle that absolute peak moment. But what about at 3 a.m. on a Tuesday? 95% of those expensive servers would just be sitting there, idle, drawing power, costing money, waiting for the next Friday night. It's like buying a 500-seat stadium for your kid's birthday party. With the cloud, with AWS, this problem vanished. Instead of a fixed number of servers, they had a virtually infinite pool of computing power on tap. When that Friday night rush hit, Netflix's software automatically told AWS, "We need more power. Spin up 10,000 more virtual servers right now." And in minutes, they were there. As people logged off and went to bed, the system would say, "Okay, we can scale back down. Release those servers." And poof, they were gone. And Netflix stopped paying for them. They only paid for exactly what they used second by second. This elasticity wasn't just a cost-saving measure. It was their strategic weapon. It meant they could handle the global premiere of Stranger Things with the same confidence as a slow Tuesday morning. It gave them infinite scale on demand. Then there was the problem of reliability. Their 2008 database crash was a single point of failure. The cloud was designed to eliminate that. AWS isn't one giant data center. It's a global network of them, organized into what are called availability zones. You can think of these as identical digital fortresses, miles apart but connected by superfast fiber. Netflix designed their new system to run simultaneously across multiple zones. So if a whole data center in Virginia gets knocked offline by a thunderstorm, you don't even notice. Your movie doesn't even buffer. The system instantly and automatically reroutes your stream from another data center in Ohio or Oregon. This redundancy, this resilience, was something they could have only dreamed of building themselves. To test this new superpower, Netflix engineers famously created a program called Chaos Monkey. Its job was to fly around their own systems on AWS and randomly break things. It would deliberately shut down servers and sever network connections, without warning, during the middle of the workday. The goal was to force their engineers to build a system so resilient, so self-healing, that it could withstand constant, random failures. They weren't just using the cloud, they were mastering it, pushing it to its limits. But the most profound change was yet to come. The cloud didn't just give them scale and reliability, it gave them intelligence. With this immense, flexible computing power, they could now collect and analyze a staggering amount of data. Every time you press play, pause, rewind, or abandon a movie halfway through, that's a data point. What you watched before, what you watch after, what you search for, what image on the screen made you click, it all went into the system. They used this data to power their world-famous recommendation engine, the algorithm that knows what you want to watch before you do. But then they took it a step further. They analyzed what the entire country was watching. They saw that people who liked the director David Fincher also liked the actor Kevin Spacey, and that the original British version of House of Cards was a hit. The data screamed that a US version, directed by Fincher and starring Spacey, would be a massive success. In the old world, a TV executive would have trusted their gut. Netflix trusted the data. They bypassed the pilot process, ordered 2 full seasons for $100 million, and created a global phenomenon that put them on the same level as HBO. The cloud wasn't just delivering their content anymore. It was telling them what content to create. It transformed them from a tech company that licensed movies into a full-blown, data-driven Hollywood studio. Netflix became the poster child for the cloud. They proved that it was possible to run a massive, global consumer-facing business entirely on rented infrastructure. They could launch in 130 countries on the same day because they didn't need to build a single data center. They just had to tell AWS to allocate them more capacity in Europe, Asia, and South America. They outmaneuvered, outscaled, and out-innovated every traditional media company on the planet. Blockbuster was just the first casualty. The cloud was the weapon, and Netflix had shown the entire world how to wield it. Their success was a signal flare for every other ambitious startup in Silicon Valley. The message was clear. You no longer need millions in venture capital to buy servers. All you need is a credit card and a brilliant idea. The gatekeepers were gone. The revolution that Amazon had started was no longer a theory. It was a reality, streaming in high definition into millions of American living rooms. Netflix had proven you could put an entire movie studio in the cloud. But other founders were starting to ask an even bigger question. If you can trust the cloud with a 2-hour movie, what about something more personal? What about every document you've ever written, or every single photograph you've ever taken? That question, the one about trust, was the single biggest hurdle. For years, the physical object was king. You held your photos in an album. You saved your term paper on a floppy disk, then a CD, then a USB thumb drive. Your data was something you could put in your pocket. It was tangible. The idea of sending your most private, most important files, your tax returns, your novel, your baby pictures, into some invisible ethereal cloud felt less like progress and more like insanity. It was like handing your house keys to a stranger. Who would do that? The answer, it turned out, was someone who was really tired of losing his keys. In 2007, an MIT student named Drew Houston was on a bus from Boston to New York. He planned to get some work done on the 4-hour trip, but when he reached into his pocket, his heart sank. He'd forgotten his USB drive. Again. All his files, all his code were sitting on his desk back in his apartment. The entire trip was a waste. And in that moment of intense frustration, a light bulb went on. He thought, I never want to have this problem again. He opened his laptop right there on the bus and started writing the code for what would become Dropbox. The idea wasn't just to store files online. Services for that already existed, but they were clunky. You had to manually upload a file, then manually download it somewhere else. It was a chore. Houston's idea was different. It was magical. What if you had a special folder on your computer, and any file you dropped into it would just appear on all your other computers, instantly? No uploading, no downloading, no thinking. It would just work. You save a Word doc on your desktop in Chicago, and by the time you walk over to your laptop, it's already there, waiting for you. You take a photo on your phone in Miami, and it's on your computer in Seattle before you've even taken your jacket off. This was the solution to a universal American frustration. We've all felt that panic of a lost thumb drive. The chaos of emailing a file to ourselves with a subject line like Final Paper Version 4 Final, use this one. Dropbox promised to end all that. But they still had to overcome that massive wall of distrust. To do that, they released a simple 3-minute demo video. It wasn't flashy. It was just Drew Houston's voice over a screen recording, showing how the magic folder worked. He dropped a file in, and it appeared on another computer. He changed a file, and the change synced instantly. He posted that video to a small online forum for tech enthusiasts called Hacker News. The response was explosive. The sign-up list for the beta version went from 5,000 people to 75,000 people. Overnight. Why? Because the video didn't just tell people about a product. It showed them a solution to a problem they didn't even realize could be solved. The convenience was so profound, so immediately obvious, that for many it started to outweigh the fear. Dropbox was offering a deal. Give us a little bit of your trust and we will give you back a huge amount of your time and sanity. We'll give you peace of mind. And they backed it up with serious technology. They didn't just upload your file. They encrypted it, essentially scrambling it into a secret code that only you had the key to. Then they used a technique called Delta Sync. This was brilliant. If you had a 500-page manuscript and you changed one sentence, older services would have to re-upload the entire massive file. It was slow and inefficient. Dropbox, however, would only sync the tiny little change you made, the delta. This made it feel instantaneous, almost like magic. Suddenly, this little startup from Boston had kicked a hornet's nest. The tech giants who had been focused on bigger, enterprise-level cloud problems suddenly woke up. They realized the personal cloud wasn't a niche market. It was the market. And nobody was better positioned to fight this war than Google. Google had a massive strategic advantage. Hundreds of millions of people were already living inside its ecosystem. They had Gmail for email. They had Google Calendar for their schedules. And crucially, they had Google Docs. Since 2006, Google had been quietly showing the world that your documents didn't need to live on your computer at all. You could create and edit a document entirely within your web browser. It was a radical idea, and it set the stage for their masterstroke, Google Drive. Launched in 2012, Google Drive wasn't just a magic folder like Dropbox. It was the central nervous system for your entire digital life, at least your Google One. It was a place for your photos, sure, but it was also the home for every Google Doc, every Google Sheet, and every Google Slide you ever created. It was seamlessly integrated with Gmail, so you could save an attachment directly to your drive with a single click. They gave every user a generous chunk of free storage, turning millions of casual users into daily cloud dependents overnight. The battle wasn't just about storing files anymore. It was about owning the entire workflow. Then, of course, there was Apple. Apple's philosophy was never about giving you a folder. It was about making the technology disappear completely. With the launch of iCloud, they baked cloud storage into the very fabric of the iPhone, the iPad, and the Mac. Your photos didn't go to a cloud folder. They just appeared in the Photos app on all your devices. Your contacts, your calendar, your notes, they were just everywhere you were. You didn't have to think about it. For the millions of people inside Apple's walled garden, iCloud wasn't a service you signed up for. It was an invisible promise that your digital life would remain perfectly in sync, no matter what device you picked up. And Microsoft, the original king of the desktop, wasn't going to be left behind. They rebranded their SkyDrive service into OneDrive and integrated it deeply into Windows and, more importantly, into Microsoft Office. The message was clear. If you live and breathe in Word, Excel, and PowerPoint, then OneDrive is your native home in the cloud. This fierce competition, the storage wars, was incredible for the average American. Prices plummeted, free storage amounts ballooned, and the technology got better and better. But the most important thing that happened was a fundamental shift in our collective mindset. We learned to trust. We learned because these companies invested billions in making the cloud more reliable than our own hardware. Here's how they did it. When you upload a precious photo of your family to Google Drive or iCloud, you're not just saving it to one computer in a warehouse somewhere. The system instantly makes multiple copies of that file. Then it stores those copies on different servers with different power supplies in different rows of the data center. But it doesn't stop there. It then copies those copies to entirely different data centers in different states, hundreds or even thousands of miles apart. Your one photo might have a copy on a server in Virginia, another in Ohio, and a third in Oregon. If a tornado takes out the entire Virginia data center, your photo is fine. If an earthquake hits Oregon, your photo is fine. The system is designed for failure, anticipating every possible disaster to ensure that your single, irreplaceable file is essentially immortal. The odds of losing a file stored this way are astronomically lower than your own laptop hard drive crashing or your house being flooded. This incredible, invisible safety net is what finally broke down that wall of distrust. The cloud became safer, more convenient, and more reliable than that old USB drive in your pocket. It changed how we work, allowing teams across the country to collaborate on a single document in real time. It changed how we live, giving us the peace of mind that our life's memories were safe from fire, theft, or simple human error. We had successfully outsourced our personal hard drives. We had given our files and photos to the cloud. But this was just the beginning. The next frontier wasn't about our documents. It was about something far more intimate, our relationships, our friendships, our entire social identity. The great migration of our data was complete. We had entrusted our digital lives to these invisible, powerful data centers. And in doing so, we set the stage for a revolution that would redefine the very concept of community. Before the cloud, connecting with friends online was a clunky, fragile affair. Think of early Facebook or MySpace. You'd upload a photo album from your spring break, and it would take an eternity. The site would buckle under the pressure every day at 3:30 p.m. when school let out. Pages would crash. Features were limited. Why? Because these companies were running on their own physical servers, a fixed number of machines sitting in a closet or a rented data center. They had to guess how much capacity they needed. Guess too low and the site crashes, angering users. Guess too high, and you've spent millions on expensive hardware that's just sitting there, burning electricity and collecting dust. This was the great scaling problem. For a social network, growth isn't a steady, predictable line. It's an explosion. It's a lightning strike. One day you have 1,000 users, the next you're featured on the news and 1 million people are trying to sign up at the same time. How do you prepare for that? The honest answer was, you couldn't. It was like building a house. You could build a house with 5 bedrooms, but if 50 people show up for a party, the whole thing collapses. You could, in theory, build a 50-bedroom mansion just in case, but you'd be broke, and 99% of the time you'd be living in a giant, empty, expensive shell. This single problem was the graveyard of thousands of promising internet startups. They weren't killed by a bad idea. They were crushed by the weight of their own success. And then the cloud changed the rules of the game. It offered a new model, something that had never been possible before: elasticity. Instead of buying the house, the cloud allowed you to rent a magical, elastic event space. If 10 friends show up, the space is a cozy room. If 1,000 people show up, the walls instantly expand to become a ballroom. If 1 million people show up, it becomes a stadium. And crucially, when everyone leaves, it shrinks back down to a small room, and you only ever pay for the exact amount of space you used for the exact amount of time you used it. This wasn't just a better option, it was a completely different dimension of thinking. It took the guesswork, the massive upfront cost, and the terrifying risk of scaling, and threw it all out the window. Now, you didn't need millions of dollars in venture capital to buy servers. You just needed a credit card and an idea. And this is where the story of the apps on your phone truly begins. Consider Instagram. When it launched in 2010, it was run by a tiny team. It was a simple app for sharing filtered photos. And America fell in love with it instantly. It exploded. In 2 months, it had 1 million users. In a year, 10 million. They didn't own a single server. The entire operation, every photo you uploaded, every filter you applied, every like you gave, was running on Amazon Web Services. Without the cloud, Instagram would have been a smoking crater in the history of the App Store. They would have needed an army of engineers and a fortune in hardware just to keep the lights on. Instead, as more users signed up, they just swiped the credit card and rented more of that magic space from Amazon. The cloud allowed them to focus on one thing and one thing only: building a great app. Or think of the infamous fail whale. The cartoon whale held up by birds that would appear whenever Twitter crashed. For years, that whale was a constant presence, a symbol of a platform buckling under its own chaotic, real-time nature. Every major world event, from the World Cup to a political debate, would send a tidal wave of traffic that their servers couldn't handle. Twitter's long, difficult journey to stability was a journey into the cloud, rebuilding their architecture to be more elastic, more resilient, more capable of handling the entire world talking all at once. And today, this has reached a scale that is almost impossible to comprehend. Take TikTok. The engine behind TikTok isn't just a bunch of servers storing funny videos. It's one of the most sophisticated machine learning and data processing operations on the planet. Every single time you swipe on your For You page, you are sending a signal. Did you watch the whole video? Did you watch it twice? Did you share it? Did you swipe away in less than a second? All of that data is fed into an algorithm running on a massive cloud infrastructure. That algorithm then has to, in a fraction of a second, analyze your personal history and the behavior of millions of others, and then select the one perfect video out of a library of billions to show you next. This is a level of computation that, just 15 years ago, would have been reserved for a government supercomputer calculating missile trajectories. Today, it's used to figure out if you prefer cat videos or cooking tutorials. And it's doing it for over 1 billion people simultaneously. That cannot exist without the cloud. Let's break down what happens in that single second you tap post on a photo of your lunch. In that instant, your phone isn't just sending one picture to one place. It's sending that data to a cloud data center, let's say in Northern Virginia. Instantly, that data center makes multiple copies of your photo and distributes them across several different machines, and even to other data centers in places like Ohio or Oregon. This is redundancy. If one hard drive or even an entire building were to be destroyed in a fire, your photo is still safe. At the same time, the cloud is automatically creating multiple versions of your photo. A high-resolution one, a medium-sized one for feeds, a tiny thumbnail. Then, the cloud's notification service fires off a signal to all of your followers. When your friend in California opens their app, they aren't pulling that photo all the way from Virginia. The cloud has already anticipated this, and using a service called a Content Delivery Network or CDN, it has placed a copy of your photo on a server just a few miles from your friend's house. That's why it loads instantly. Every like, every comment is a transaction written to a database, also running in the cloud, which is also copied and backed up in real time. This is the invisible miracle powering our social lives. The cloud took social media from being a novelty, a digital scrapbook you checked once a day, and turned it into a real-time living extension of human consciousness. The infinite scroll, the 24-hour story, the live stream from a concert, these features are only possible because of the cloud's promise of infinite, on-demand computing power. It democratized fame and influence, allowing anyone with a phone to potentially reach an audience of millions without needing the permission of a gatekeeper. It fundamentally rewired how we communicate, how we organize, how we fall in love, and how we see ourselves. But our social lives were just one pillar of our culture that the cloud was about to upend. This same on-demand, infinitely scalable infrastructure that allowed us to share our lives with each other was about to be pointed at one of the most powerful and storied industries in America. The revolution wasn't just about what we created, it was about what we consumed. The next target was Hollywood, and the battle would be streamed directly into our living rooms. For a century, Hollywood was an impenetrable fortress built on film reels, broadcast towers, and billion-dollar backlots. Its power was absolute. It dictated what you watched, when you watched it, and where you watched it. The entire American entertainment schedule was a carefully constructed ritual. Must-see TV on Thursday nights, the Saturday matinee at the local cinema, the Sunday night blockbuster premiere on HBO. You bought a ticket at the box office, you tuned in at 8 p.m. sharp, or you waited months for the blockbuster release. The moguls in their corner offices on Sunset Boulevard were the gatekeepers of American culture, and their business model was rock solid, or so they thought. Because while they were greenlighting sequels and signing movie stars, a small company in Los Gatos, California was mailing out DVDs in little red envelopes. Netflix. To the Hollywood giants, it was a harmless novelty, a quirky mail-order service, a minor inconvenience to Blockbuster perhaps, but certainly not a threat to the multi-billion-dollar ecosystem of theatrical releases and broadcast rights. They saw the red envelope, but they didn't see the Trojan horse. They didn't understand that Netflix wasn't a DVD company. It was a logistics and data company biding its time, waiting for one crucial piece of the puzzle to fall into place: the internet in every American home, and the cloud to power it. The first challenge was storage. A physical video store is limited by its four walls. It can only hold a few thousand tapes or discs, but a digital library could be infinite. The problem was, building the server farms to house a digital library of thousands of movies and TV shows would have cost a fortune, hundreds of millions in upfront investment. It was a barrier so high only the biggest players could even attempt it. But with the cloud, specifically Amazon Web Services, Netflix didn't have to build the warehouse. They could rent shelf space. They could upload their entire catalog to Amazon's S3 or simple storage service, paying pennies per gigabyte for a virtually limitless, incredibly durable digital vault. The fortress walls were being bypassed, not by an army, but by a credit card and an API call. But storing the movies was the easy part. The real monster was delivery. Think about it. When you press play on your TV, you are one of millions of people all trying to watch something at the same time. And you're not all using the same device. You might be on your 4K television connected to fiber optic internet. Your neighbor might be on their iPad over spotty Wi-Fi. Someone across the country is on their Android phone using a cellular connection. Each one of those devices, each one of those internet speeds requires a completely different version of the same movie file. This process is called transcoding. A single master file of a movie has to be crunched, converted, and repackaged into dozens of different formats and quality levels. This takes an astronomical amount of raw computing power. For a traditional company, it would mean building a data center full of processors that would sit idle most of the day, only to roar to life during primetime hours. It would be fantastically expensive and inefficient. But for Netflix running on the cloud, it was a superpower. Using Amazon's EC2 or Elastic Compute Cloud, they could summon a virtual army of thousands of computers whenever they needed them. When a new season of a hit show dropped, they could spin up 10,000 servers to transcode it for every device imaginable. And once the job was done, they could shut them all down and stop paying for them. The cloud gave them the power of a Hollywood studio's render farm, on demand, for a fraction of the cost. Finally, there was the last mile, the physical distance between the server and your screen. If a server in Virginia had to send a movie to a viewer in Los Angeles, the data would have to travel over 2,500 miles, hopping through dozens of network points. The result? Buffering, lag, frustration. The magic of instant streaming is an illusion, and it's an illusion created by content delivery networks or CDNs. Using a service like Amazon's CloudFront, Netflix could place copies of the most popular shows and movies in data centers all over the country and the world. When you press play on Stranger Things in Chicago, you're not pulling it from a master server on the coast. You're streaming it from a server that might be just a few miles away, right there in the Midwest. The cloud turned the entire United States into a local video store, with a copy of what you wanted waiting just around the corner. Armed with this trinity of cloud powers, limitless storage, on-demand computing, and a global delivery network, Netflix was ready to attack the fortress. In 2007, they launched their Watch Now streaming service. At first, the Hollywood giants scoffed. The selection was small, the quality was grainy. It was a cute feature, nothing more. They continued to license their older, less valuable content to Netflix for a nice little paycheck, never imagining they were handing their future executioner the very weapon he would use against them. The turning point was February 1, 2013, the day House of Cards was released. This wasn't a licensed show. This was a Netflix original. The company had used the massive trove of viewing data they'd collected, all stored and analyzed in the cloud, to make a calculated $100 million bet. They knew their users loved David Fincher movies. They knew Kevin Spacey films performed well. And they knew political thrillers were a hit, so they brought them all together. It was a creative decision driven by big data. But the most revolutionary part wasn't the show itself. It was how it was released. All 13 episodes all at once. This was a direct declaration of war on the weekly broadcast model that had defined television for 60 years. It was an act of rebellion only possible because of the cloud. Imagine the surge in demand. Millions of people across the US all trying to stream the first few episodes at the exact same time on a Friday night. A traditional server infrastructure would have melted. But Netflix's cloud architecture was built for this. It flexed, it scaled automatically, summoning more compute power, more bandwidth, seamlessly delivering a flawless experience. The binge watch was born, and American culture was forever changed. Suddenly, Hollywood wasn't laughing anymore. They were terrified. They saw their entire business model of scheduled programming and controlled releases crumbling before their eyes. The reaction was a frantic, panic scramble. Every major media conglomerate, Disney, Warner Brothers, NBC Universal, Paramount, realized they had to launch their own streaming service to survive. And where did they all have to go to build them? They had to go to the cloud. They had to become customers of Amazon, Microsoft, and Google, the very tech giants disrupting them. The media titans of the 20th century were now tenants in the digital empires of the 21st. For the American viewer, the world shifted. The remote control became the most powerful tool in the house. We were no longer passive recipients of a pre-programmed schedule. We were curators of our own personal on-demand film festivals. The concept of primetime evaporated. The water cooler conversation changed from "Did you see that last night?" to a cautious "Where are you in the season?" No spoilers. The cloud hadn't just changed how movies were delivered. It had fundamentally rewired the daily and weekly rhythms of American life. This complete reinvention of a 100-year-old industry, from production to consumption, was a stunning display of the cloud's power. But entertainment was just the beginning. The same principles, using massive data, providing on-demand service, and leveraging scalable infrastructure, were about to be aimed at an industry even more fundamental to our daily lives. The battle for our living rooms was over. The battle for our streets was about to begin. And it began not with a bang, but with a tap. A single tap on a piece of glass in your hand. Before this tap changed everything, getting around an American city was a game of chance. You'd stand on a street corner, arm outstretched, a supplicant to the city's chaotic flow, hoping a yellow cab would materialize. Or you'd call a dispatcher, a disembodied voice in a crackling call center, who would take your information and offer a vague promise, 20 to 30 minutes. You'd wait, staring out the window, wondering if they'd forgotten you, if the cab was lost, or if it was ever coming at all. The entire system was a black box. You had no idea where the cars were, who the driver was, or what the price would be until the meter stopped spinning. It was a system built on analog friction and blind faith. Then, in 2009, an idea so simple it seemed almost obvious emerged. What if you could summon a car with your phone? This wasn't just about building a better taxi company. It was about building a software company that managed a network of independent drivers and riders. The goal was to replace the friction of the old world with the seamless, on-demand magic of the digital one. But this magic was, in reality, a series of monumental computational problems, each one so complex, so demanding, that it would have been impossible to solve just a few years earlier. The only reason this revolution could even get off the ground was because the cloud was there to catch it. Think about the first, most basic function. Seeing the little car icons moving on a map on your phone. It looks simple, feels intuitive, but behind that screen is a logistical nightmare. Every single driver's phone is a beacon, constantly transmitting its GPS coordinates, its latitude and longitude, up to the cloud multiple times per second. Simultaneously, every person with the app open is also sending their location. In a city like New York or Los Angeles, this means millions of data points are flooding into a central system every single second of every single day. A traditional self-hosted server would melt under this kind of constant high-velocity data stream. It's not just about receiving the data. You have to process it, index it, and make it searchable in real time. The cloud, with services like Amazon's Kinesis for data streaming and DynamoDB for high-speed databases, was built for exactly this kind of firehose. It could ingest this torrent of location data from millions of devices without breaking a sweat, and then almost instantly, serve it back out to every user's map. That little car moving smoothly across your screen isn't a simple animation. It's the end result of a massive, distributed cloud architecture performing trillions of calculations to give you a real-time view of your city's pulse. But knowing where the cars are is just the first step. The real challenge, the core of the entire business, is the match. When you tap that Request Ride button, a silent, high-stakes auction begins in the cloud. The system doesn't just find the closest driver. That would be too simple and wildly inefficient. Instead, a sophisticated algorithm, running on a fleet of powerful cloud servers, instantly analyzes a staggering number of variables. It looks at the location of every available driver, but it also factors in real-time traffic data from services like Google Maps to calculate the actual time it will take for each driver to reach you. It considers the driver's rating, the type of vehicle, and even the direction they are currently heading. It looks at your rating as a passenger. It analyzes the driver's current destination preference, if they have one. All of this data is churned through a complex optimization model in a fraction of a second. The system runs thousands of potential scenarios simultaneously to find the single most optimal pairing of rider and driver to minimize wait times across the entire network, not just for you. This isn't something you can run on a single server in a back office. This requires the kind of immense, on-demand computational power that is the hallmark of cloud computing. It's the ability to spin up thousands of virtual processors for a few milliseconds to solve an incredibly complex logistical puzzle, and then spin them back down again, paying only for the exact computation used. And then there's the most famous, or infamous feature of all, surge pricing. This is the cloud's principle of elasticity made visible in our daily lives. Think about a city after a major concert or a football game lets out. Tens of thousands of people all want a ride at the exact same moment. In the old taxi world, this meant chaos. Not enough cabs and no way to signal for more. The ride-sharing platforms, however, use the cloud to perform a delicate and brutal dance of supply and demand. As the demand in a specific geographic area spikes, the algorithms running in the cloud detect this imbalance instantly. The price for a ride begins to rise. This price increase, displayed as a surge, does two things. First, it tempers demand, encouraging some people to wait or find other options. Second, and more importantly, it sends out a powerful economic signal to every driver in the surrounding area. The map on their app literally lights up, showing them where the demand and the money is. This incentivizes drivers who were off duty to log on, and drivers in quieter parts of the city to head towards the surge zone. The cloud infrastructure has to scale elastically to handle this. The number of calculations, the data processing, the map updates, everything explodes during a surge. An infrastructure built on physical servers would have to be provisioned for the absolute peak demand, for that New Year's Eve rush, meaning it would sit idle and wastefully expensive 99% of the time. But the cloud allows these companies to rent a supercomputer for the 30 minutes they need it, scaling their server capacity up by a factor of 10 or even 100, and then scaling it right back down when the crowd disperses. Surge pricing isn't just a pricing strategy. It's a real-time load balancing system for an entire city's transportation network, orchestrated entirely by the cloud. Beyond the real-time operations, the cloud became a vast learning machine. Every trip, every route, every rating, and every dollar spent was a data point. All of this information was stored and processed in massive cloud-based data warehouses. Using cloud machine learning tools, these companies could now analyze patterns on a scale never before imagined. They could predict traffic flow, forecast demand for drivers in specific neighborhoods hours in advance, and identify the most efficient routes. They began to understand the very rhythm of a city, where people go for lunch on a Tuesday, how a rainstorm affects travel patterns, where the nightlife hotspots are on a Friday. This wasn't just about giving one person a ride. It was about optimizing the transportation grid of an entire metropolis. The app on your phone was merely a key. It unlocked the power of a colossal, invisible factory that was constantly working in the background. A factory with no smokestacks or assembly lines, but with racks upon racks of servers in anonymous data centers spread across the country, all networked together. This cloud-powered factory took the messy, unpredictable reality of our streets and transformed it into an orderly, efficient, on-demand service. The battle for the streets was won not by having more cars, but by having the most intelligent, scalable, and powerful brain in the cloud. This model of using the cloud to orchestrate a vast, decentralized network of real-world assets was a game-changer. It had conquered our entertainment and our transportation. Now the same playbook, real-time logistics, supply and demand balancing, and massive data analysis, was about to be turned on one of our most basic human needs. The battle for our streets was over. The battle for our dinner plate had just begun. The logistics of getting a person from point A to point B seem complex, but they are beautifully simple compared to the controlled chaos of getting a hot meal from a kitchen to a doorstep. This isn't a two-sided equation. It's a three-sided high-stakes ballet. You have a hungry customer, a busy restaurant, and an independent driver. All three have different goals, different timelines, and are in constant motion. Before the cloud, coordinating this dance in real time, at the scale of an entire city, was a fantasy. It was a logistical Rubik's Cube with a million moving pieces. The app on your phone, whether it's DoorDash, Uber Eats, or Grubhub, acts as the choreographer, and its brain lives entirely in the cloud. When you tap Place Order, you're not just sending a message to a restaurant. You are initiating a cascade of calculations that would have buckled a supercomputer just a generation ago. First, the system has to confirm the restaurant can even take your order. Is the kitchen overwhelmed? Are they out of an ingredient? The app's cloud platform is integrated directly with the restaurant's own systems, getting a live pulse of their capacity. Simultaneously, the algorithm begins solving the assignment problem. It's not just about finding the closest driver. That's amateur hour. The cloud is running a far more sophisticated simulation. It's analyzing every available driver in a multi-mile radius. It knows their current location, their direction of travel, and their average speed. It knows if they're already on another delivery and, if so, where that drop-off is. Could your order be batched with another one without making your fries soggy? The system calculates the probability. A driver with a thermal bag gets a higher score for an order with hot soup. A driver on a bicycle is a poor choice for a catering order across town. All these variables are weighed in milliseconds. But the real magic, the part that separates a hot meal from a lukewarm disappointment, is the timing. The cloud doesn't just dispatch a driver. It predicts the future. Using machine learning models trained on millions of previous orders from that exact restaurant, the system estimates food preparation time. It knows that on a Friday night, this specific pizza place takes, on average, 18 minutes to make and box a large pepperoni. It knows that on a Tuesday, it's closer to 12. It then factors in real-time traffic data, fed from APIs like Google Maps, to calculate the driver's exact travel time to the restaurant. The goal is a perfect handoff. The cloud orchestrates events so the driver walks through the door the very second the restaurant staff is sealing the bag. Not 2 minutes early, leaving the driver waiting and frustrated. Not 2 minutes late, leaving your food sitting under a heat lamp. This constant predictive timing is a symphony of data, with every GPS ping from the driver's phone, every status update from the restaurant's tablet, and every traffic sensor in the city acting as an instrument, all conducted by a server farm you will never see. And just like with ride-sharing, the economics are fluid, managed by the cloud's immense processing power. On a rainy Sunday during the Super Bowl, demand for wings explodes. Suddenly, there are 10 times as many orders as available drivers. The cloud sees this imbalance instantly. It initiates dynamic pricing, or what you see as a busy fee. That extra fee isn't just a price gouge. It's a signal, an economic incentive broadcast to every driver who has the app. It's the system saying, We need you. Get on the road, and you will be compensated for it. It's a real-time, self-correcting market for delivery services, balancing supply and demand, minute by minute. But the cloud's influence doesn't stop at just delivering the food. It has begun to fundamentally change what and where we eat. For years, these delivery platforms did one thing relentlessly. They collected data. They knew what cuisines people in a specific neighborhood searched for but couldn't find. They knew that a certain zip code had a huge demand for high-quality ramen, but the closest ramen shop was a 45-minute drive away. This was a market inefficiency, a gap between what people wanted and what was available. And so, the cloud gave birth to a new kind of restaurant, the ghost kitchen. You've probably ordered from one without even knowing it. These are restaurants with no storefront, no tables, no waiters, and no physical address you can visit. They are nothing more than a kitchen, often in a shared, low-rent warehouse space, with a handful of chefs and a row of tablets, each one dinging with orders from a different app. One kitchen might be making tacos under the brand name Taco Temple for DoorDash, while simultaneously making chicken wings under the name Wing Dynasty for Uber Eats. These businesses exist only on the cloud. Their location is chosen by data analysis. Their menus are optimized based on the most searched for items in the area. They can spin up a new virtual restaurant brand in a matter of days to test a new concept. If it fails, they just turn it off in the app. No expensive lease to break, no front-of-house staff to lay off. It is the restaurant industry remade in the image of the cloud. Agile, data-driven, and virtual. The cloud isn't just a tool for restaurants anymore. It is the very foundation they are built upon. From the complex dance of a three-sided marketplace to the birth of restaurants made of data, the journey of your dinner is a testament to the invisible power of distributed computing. We've seen how the cloud moves our bodies through the city and how it moves food to our homes. It has conquered the logistics of the physical world, optimizing our movement and our meals. But its most profound impact, its final frontier, was not in conquering the world of atoms, but the world of bits. It was about to rewire the very concepts of ownership and entertainment. We've seen how the cloud moves us and feeds us, but its most profound impact might be on what it feeds our minds. From the shows we binge to the music that defines our lives, the cloud became the ultimate content delivery network, turning scarcity into infinite, on-demand abundance. And this abundance didn't just change what we watch. It created the very foundation for what we create. The same sprawling, powerful infrastructure that allows millions of Americans to stream the Super Bowl in 4K simultaneously, without a flicker, is the very same infrastructure that is now giving birth to the next great technological revolution: artificial intelligence. Think about it. The AI that can write a poem, compose a song, or help a doctor diagnose a rare disease wasn't born in a single supercomputer in a lab. It was born in the cloud. It was raised on a diet of data so vast it defies human comprehension. Trillions of words, billions of images, the collective knowledge of humanity, all stored, processed, and synthesized across thousands of servers humming in unison in data centers scattered from Ashburn, Virginia, to the Dallas, Oregon. When you ask a chatbot a complex question, you're not talking to a clever program on your phone. You are tapping into a mind that lives in the cloud, a neural network so massive that its home has to be the size of a city block, cooled by rivers and powered by a small town's worth of electricity. This is the cloud's next act. Not just storing our information, but understanding it. Not just delivering our content, but creating it. This shift is already reshaping industries in ways we're only beginning to grasp. In medicine, cloud-powered AI can analyze an MRI scan and spot a tumor the human eye might miss. It can sift through millions of medical journals in seconds to suggest treatments for a patient. In science, it can simulate protein folding or model climate change with a speed and complexity that was pure science fiction just a decade ago. It's the ultimate research assistant, the ultimate pattern finder, and it's available to any hospital or university that can connect to the internet. But the cloud's influence isn't just confined to the digital world of bits and bytes anymore. It's extending its reach, creating a nervous system for the physical world itself. This is the promise of the Internet of Things, or IoT. That smart thermostat on your wall? It's constantly talking to the cloud, learning your schedule, and checking the weather forecast to save you money on your energy bill. The fitness tracker on your wrist is sending a stream of data to the cloud, giving you insights into your health that were once only available to elite athletes. Now scale that up. Think of a farmer's field in the Midwest. IoT sensors in the soil are reporting moisture levels to the cloud. The cloud cross-references that data with satellite imagery and weather predictions, then tells the automated irrigation system exactly how much water to deliver to each specific part of the field, conserving a precious resource and maximizing the harvest. Think of a modern American factory. Every machine, every robotic arm is streaming performance data to the cloud. An AI can then predict when a part is about to fail before it breaks, preventing costly shutdowns and keeping the lines of production moving. And this leads to the next evolution, edge computing. Because for some things, the speed of light is still too slow. A self-driving car cruising down I-95 can't afford to send a video of a pedestrian stepping into the road, all the way to a data center in Ohio and wait for instructions to brake. The decision has to be instantaneous. That's the edge. The car itself has a powerful onboard computer that makes that split-second life or death decision. But here's the magic. After the event, it sends that data back to the central cloud. The cloud's AI then learns from that specific incident, from the angle of the sun to the speed of the car, and shares that lesson with every other car in the fleet. So one car's near miss on a Tuesday in Miami can prevent an accident on a Thursday in Seattle. The edge handles the immediate action. The cloud provides the collective intelligence. It's a perfect partnership, a digital brain with a global consciousness and lightning-fast local reflexes. Of course, this incredible concentration of power and data brings with it monumental challenges. The very data centers that power our digital lives have a voracious appetite for energy. The hum of those servers is the sound of a significant and growing carbon footprint. This has sparked a race for sustainability, with tech giants pioneering new ways to cool servers with recycled water, build data centers next to renewable energy sources like wind and solar farms, and design chips that do more with less electricity. The future of the cloud must be a green one. And then there's the question of security and privacy. When our lives, our photos, our conversations, our financial data, our health records, are stored in the cloud, the security of that cloud becomes paramount. The same infrastructure that empowers a small business also presents a tempting target for bad actors. The battle for the 21st century isn't just being fought on land, sea, and air. It's being fought silently every second of every day, in the digital corridors of the cloud. Yet, despite these challenges, perhaps the most profound impact of the cloud, the one that truly captures the American spirit, is its role as the great equalizer. Before the cloud, if you had a brilliant idea for a new app or online service, you first needed a fortune. You had to buy massive, expensive servers, hire a team to maintain them, and rent physical space to house them. The barrier to entry was a mountain of capital. Innovation was a club for the rich. The cloud demolished that mountain. Today, a team of 2 people in a garage in Boise, Idaho, can access the exact same world-class computing power, the same databases, the same AI tools, and the same global delivery network as the biggest corporations in Silicon Valley. They don't buy servers, they rent them, paying only for what they use by the second. This is called the pay-as-you-go model, and it is the single greatest engine for innovation we have ever built. It has democratized digital creation. It means the next billion-dollar idea is just as likely to come from a dorm room in Austin as it is from a boardroom in New York. It's the ultimate level playing field. So, when we try to see the cloud, we shouldn't look up at the sky. We should look around us. It is the invisible architecture of our age. It's the silent, reliable utility, as fundamental as electricity or running water, that powers nearly every facet of modern American life. It's the reason your navigation app can reroute you around traffic in real time. It's the reason you can deposit a check by taking a picture with your phone. It's the reason a small business can compete on a global scale. It's the magic behind the curtain of the digital world. From a simple idea of time-sharing on a mainframe computer to a global interconnected brain, the cloud has become the foundational layer upon which our future is being built. It is not just a place where we store our files. It is where we collaborate, where we create, where we learn, and where we dream. It's the ghost in the machine, a vast and complex system of light and logic, humming quietly in warehouses you'll never see, yet closer to you than the phone in your hand. The next time you tap a screen to order a car, watch a movie, or talk to a loved one across the country, take a moment to appreciate the incredible, invisible symphony of technology that makes it possible. You are summoning the power of a continent-spanning supercomputer, all to serve you in that one single effortless instant.